In 2025, Bambu Labs released 4 brand new printers, including 3 behemoths in their new H2 flagship lineup. The latest edition, the H2C, features the new Vortek Nozzle changer, enabling multicolour prints which are not only significantly faster, but also provide almost zero waste material for up to 7 colours or materials. I've been putting the H2C through its paces ever since it landed in my workshop, and in today's video I'll be covering what it does well, some things to keep in mind if you are considering it, what the actual user experience is like to daily drive the H2C, and whether it will be a good fit for your setup. So, let's take a look. With its dual nozzle extruder, the H2D already massively cut down on waste material from multicolour prints compared to a single nozzle printer. That said, whilst it does reduce waste material no matter how many colours you're printing with, the benefits have diminishing effects when using more than 2 colours, and with 3 you're still going to get purged material, just not as much as you would with a single nozzle printer. The H2C follows the same form factor as the H2D, keeping the dual nozzle extruder setup, allowing very quick switching between 2 nozzles. But with the addition of the Vortek Nozzle changer, the right-hand nozzle in the extruder can be switched between up to 6 different nozzles. What this means is, whilst with enough AMS units you could print something with up to 24 different filaments, you're able to print something with up to 7 colours or materials, and each different filament is going to have its own nozzle for the entire print, meaning you won't need to purge any material between colour changes. The Vortek Nozzle changer is a motorised rack to the right of the build plate, which holds up to 6 nozzles. This is including the nozzle that will be fitted to the right-hand slot of the extruder. The extruder can automatically swap nozzles in and out of the rack using magnets and a locking bar, which it actuates using a bolt which is integrated into the top of the rack mechanism. Other than a few small changes like this sleek dark grey exterior, the H2C is effectively an H2D fitted with the Vortek Nozzle changer and the compatible extruder setup. In fact, if you already own an H2D or an H2S, you'll soon be able to buy the Vortek as an upgrade kit, which you can then fit to your existing printer, but with some caveats that I'll cover in a second. As it does have the same form factor, I've already seen people online buying the replacement side panels for the H2C and fitting them to their H2D and H2S for that aesthetic flair. As with the other H2 printers in the lineup, you can also get this in a laser version, which will have the green glass on the front and sides and the black glass on top, allowing you to do laser engraving and laser cutting, and you can also fit the cutter and plotter modules. As I've covered the H2D in previous videos, this one will focus on the Vortek system and what it brings to the table. Now, it is worth noting that this upgrade process is geared towards the more technically inclined, and Bambu states that it can take in excess of 12 hours to complete. Bear in mind, you're not just installing the nozzle changer, you're also replacing the extruder and the bed and a few other bits. And if you're upgrading from the H2S rather than the H2D, it's an even more involved process, so just keep that in mind whilst you're weighing up your options. The other thing to keep in mind is the main sacrifice you make choosing the H2C over the other H2 printers. Whilst they're all the same size, to make room for the Vortek Nozzle changer, the H2C has a smaller build volume than both the H2S and the H2D.
Now, I know this is a lot of numbers, but hopefully the on-screen graphics will help you here. Where the H2S has a build volume of 340 by 320 by 340 mm, and the H2D has a build volume of up to 350 by 320 by 325, the H2C has a build volume up to 330 by 320 by 325.
Buying an H2S or H2D with the bigger build volumes and then installing the Vortek upgrade isn't going to get you around this, as part of that upgrade process is swapping to a smaller print bed. But there is a very slight silver lining to this. The reason the H2D and H2C build volumes can vary is because it depends which nozzle you're printing with, the left, the right, or both, and which part of the build plate they can reach. On the H2D, there's a strip either side of the build plate that only one nozzle can reach. That's because the extruder doesn't have enough travel in either direction for both nozzles to cover the full width. You could argue that they should have made that x-axis larger to allow both nozzles to reach the entire plate, but that would have meant making an already very large printer even bigger, at which point you could then say, well, they should have put in a bigger build plate because there's now room for it, and then we just enter this vicious cycle. With the H2C, the extruder needs to move past the build plate to access the Vortek nozzle rack on the right. To accommodate this, they trimmed off the right side of the build plate. Technically, the maximum build volume is now smaller, but in practice, most of what was lost, at least in the x-axis, was already unreachable by the left nozzle anyway. As a result, the left nozzle can now reach almost the entire build plate, except for a narrow 5mm strip along the right edge. Whilst the internal structure of the nozzles used by the Vortek system work on the same principles as any other, they are far from conventional nozzles. Traditionally, a nozzle is heated by a heating element fitted within a metal block, which is either fitted around the nozzle or positioned next to it. The heating element heats up the block, and then that block transfers heat to the nozzle. The Vortek nozzles are referred to as induction nozzles, as when fitted into the extruder they have a coil wrapped around them which uses induction technology to heat up the nozzles directly in 8 seconds. The induction nozzles are not just blocks of metal. They feature onboard heat-resistant chips and ultra-short-range contactless data transfer to communicate with the printer, allowing the onboard thermostat temperature to be read, whilst also allowing instant identification of which nozzle is fitted. We'll dig into what that actually means a little later, but whilst we're already at the extruder, there's something else you might have noticed. The Vortek rack can hold up to 6 induction nozzles, including the one that's fitted into the right slot on the extruder. But the left slot on the extruder doesn't use induction nozzles. This uses the same nozzle type as the H2D and H2S, which is almost identical to that of the A1 nozzles, and there is some cross-compatibility there. At first glance, this may seem frustrating that you need 2 types of nozzles and can't just swap one of your induction nozzles into the left slot on the extruder, but this is actually a good thing for you, the consumer. Because of the technology in these induction nozzles, they are twice as expensive as the standard H2 nozzles. As the left slot doesn't require any of this tech, you're not losing anything by using this cheaper style nozzle. It also means if you're upgrading your H2D or H2S using the Vortek upgrade kit, you can still use any nozzles you've already bought. Another difference between the H2C and the H2D is this extruder cover. This features a built-in fan to help prevent nozzle blockages from things like heat creep with better temperature control. It also features this lit indicator on the top to show you which nozzle is currently in use. Just like with the Vortek upgrade system, this can also be purchased as an upgrade for other H2 printers. Whilst there is some really cool technology in this, we've had tool head changers for years which swap between entire extruder carriages. These are great because you can then keep the filament fully loaded rather than having to load and unload between an AMS each time, and also means that you can preheat one before the previous extruder has finished printing. However, these require significantly more space, meaning a larger printer. They can also be a lot more expensive, and with more extruders means there is more potential points of failure. A nozzle changer allows most of the advantages of a tool head changer whilst keeping a more compact form factor and saving the costs of multiple extruder systems. With the announcement of the impressive Prusa Index, the Vortek isn't the only recent nozzle change system. But the H2C doesn't just have a nozzle change system, it is paired with a dual nozzle extruder. This means it can always have 2 nozzles pre-loaded and ready to go, switching between them during a print even faster than a tool head changer. By combining a nozzle changer and a dual nozzle extruder, it massively cuts down on the filament swap times mid-print, without the need for multiple extruders or a larger printer. Now, to make the most of your Vortek system, which features 6 induction nozzles and 1 fixed nozzle, you obviously need to be able to fit at least 7 filaments to your printer at once. The catch is that 6 of those need to be connected to the right-hand nozzle. Whilst you can have multiple AMS connected to a single printer at once, each AMS can only be directed to a single nozzle. That said, Bambu Labs does have a patent for an AMS design with multiple outputs, and their CEO Dr. Yi Tao has said that that's something they're actively working on. The simplest and cheapest solution is to have two AMS connected to the right-hand nozzle, giving you 8 filaments available for the right-hand nozzle, then using an external spool on the left nozzle. This will work absolutely fine if most of your prints use the same default colour and material that you can then just leave on the left nozzle. But for real-world practicality, you'd likely want an AMS for the left nozzle too. Something that's reflected with Bambu Lab giving you the option to either buy the printer as standard, which comes with one AMS2 Pro, or the Ultimate set, which comes with two AMS2 Pros and an AMS HT, which collectively can hold 9 filaments. That said, for many people, one AMS on either side may be the perfect solution, and something I'll touch on in a minute. Printing in multiple colours or materials at once is great, but for me one of the biggest advantages of the AMS is the ability to have multiple filaments loaded at all times. So when I need to send a print, there's a much bigger chance that the filament or filaments that I need are already loaded and ready to go, especially useful when starting a print remotely. The Vortek brings a similar advantage to the nozzles. As well as allowing you to print 7 colour or material prints with almost zero waste, it also allows you to have different size nozzles racked at the same time. So I tend to leave one 0.2mm and one 0.6mm nozzles loaded on the rack, along with 4 0.4mm ones. This means I'm always ready to run a 0.2 or 0.6mm print or a 5 colour print with minimal waste without having to swap any nozzles. If that's how you would generally run your system, you would get by just fine with just a single AMS connected to the right hand side. For the left hand side, you could either just use an external spool, or you could have a second AMS for the left, which you swap over to the right when you want to print more than 5 colours. But when I do need to swap these induction nozzles out, is that going to be a right hassle with this complicated looking system? Bambu Labs has progressively made changing nozzles faster and easier. With the X1 and P1 range, it was already a huge step up from conventional nozzles, but did require plugging in and unplugging 3 different cable connectors. The A1 range took it one step further and made it extremely easy, just removing the silicone sock, unclipping it and removing it. But swapping an induction nozzle on a Vortek rack really could not be quicker or easier. The rack is split into 2 sets of 3, A and B. Just tap on the one you want on the screen and the rack will raise it up. You can then literally just pick up the nozzle you want, pulling it away from the rack, and simply place the new one there, lining up these 2 magnetic spikes with the holes on the side of the heatsink. There's an indicator on each of the rack slots to show you which slots are occupied, so you can quickly see if you've fitted it correctly. All in all, you could swap between 2 nozzles in less than 5 seconds. Whilst you can load different size nozzles into the rack at the same time, unfortunately you can't yet use different size nozzles within the same print. Imagine using a 0.2mm nozzle for outer walls to get fine detail, 0.4mm for inner walls, and 0.6mm for infill. That would seriously speed up prints without sacrificing surface quality or detail. Both the H2D and the H2C are technically capable of this. It's just a software limitation, and from what I've heard, Bambu Lab are working on it, so hopefully this is a feature we'll see rolled out fairly soon. If not before, I would love to see this as one of the headline additions to Bambu Studio version 3, whenever that drops. Not only is it great for multicolour prints, the H2C is much better equipped than a single nozzle printer for printing with multiple materials, whether all in one print or separately. Allowing up to 7 different materials to each have their own nozzle guarantees there will be no cross-contamination between materials.
As both the material and colour of the last filament used is saved to the onboard chip of the nozzle, the H2C will always prioritise that nozzle when printing with that material and a close colour next print.
So we've had a look at the Vortek system, now let's have a quick look at the differences with slicing and then we'll do some test prints. The slicing process for the H2C isn't too different from the H2D, and I'll cover it more thoroughly in a dedicated video, but here's a couple of differences that you may notice. Other than the build plate, which we've already looked at, when it comes to sending the print, you can not only choose which filament you want to use from your AMS, but you can also choose which nozzle that filament is printed with. The nozzles will be pre-assigned based on what materials and colours were last loaded into them. Whilst the H2C doesn't need to purge material mid-print when you're using 7 materials or less, if the filament you've loaded is a different material or colour to that which was previously loaded in that nozzle, it will need to do a purge the first time that nozzle is used at that print. So we've looked at what the H2C is, how the Vortek works, and how you use it. But how does it actually perform? Let's do a few prints. I'm not sure if it speaks more to my confidence in Bambu Lab or just my own naivety, but the very first print that I did on this system after setting it up wasn't a benchy, it wasn't one of the preloaded test prints, but it was the 7-colour robotic reindeer that I'd made for a previous video. Jumping straight into the deep end with a 7-colour 12.5-hour print with thin geometry and fair amounts of support material may not have been the safest first print, but it went perfectly and without a hitch other than my gold filament that desperately needed drying. I've run the printer pretty much non-stop since then, constantly bashing out multicolour and material, Christmas gifts and decorations and more. But I wanted to do some prints specifically for this video. The main one I had in mind that I wanted to do was Print Cat, ironically by user 3D Print Dogs, a runner-up in the Maker World Vortek contest and features 7 colours on almost every layer. Paint Cat was a 36-hour print with hundreds of nozzle changes and printed pretty much perfectly. It's a great design and was a fun test for the Vortek. Now it gets interesting when we look into the numbers for this print. This print used 292 grams of filament, but the model itself is only 75 grams. 10 grams was the support material, but 206 grams were used in the prime tower. This is one of the weightiest prime towers I think I've ever printed relative to the model size, but being a 7-colour print it does make sense. And remember, prime towers are there to prevent oozing, blobbing, stringing and under extrusion. And whilst you can turn these off, you can print without them, it's generally required if you want a good quality print. But has the H2C really saved us time and material if it's taken a day and a half to print, and it's printed a prime tower that weighs almost 3 times that of the actual model? Well, if we reslice it with the exact same settings but with a single nozzle printer, this would have taken 3.5 days to print and used over a kilogram of filament. So whilst, yes, technically there is still waste material from a print like this, the lack of needing to purge between filament changes mid-print has saved us 75% of our waste material. In fact, even an H2D with its dual nozzle extruder would have taken over 2.5 days and used almost 900 grams of filament. In addition to that and all the things that I've been printing on this machine since receiving it, I also did a couple of other prints specifically for this video, including a rather fetching knitted chicken which took 9 hours and used 82 grams in total, compared to 22.5 hours and 325 grams on a single printer. And I finished up with this super cute Charmander which took 8.5 hours and used 101 grams, compared to 23.5 hours and 370 grams on a single nozzle printer.
Obviously partly thanks to the design, but I'm super impressed how this Charmander came out. Honestly, it looks better quality than a lot of store-bought toys I've seen. The fine detail of the chicken is just as impressive. Sure, the knitted texture may hide some minor imperfections, but the print has really clean lines with sharp colours as well as defined shape despite the constant minor overhangs with this texture. Whilst not as thin or as angled as the antlers on my robot reindeer, the cat's tail presented a similar challenge, but the tail and legs printed perfectly, with no misalignment or warping. Thanks to each colour in these prints having its own nozzle, there's absolutely zero bleed between the colours, leaving all of them looking crisp and clean. Despite additional machine movement between colour changes, there's no ringing or ghosting from the geometry or colour changes anywhere on any of these prints. Whilst fairly simple, these prints have shown clearly that the H2C can produce some really high quality prints, even with very minimal effort. Since I received it, I've printed with PLA, PETG, PC and TPU on this H2C without any issues, but I'm planning a quick video covering how it performs with a wide range of different materials soon.
So just between those 3 simple prints, we've saved over a kilogram of filament that would have previously just been waste material on a single nozzle printer. If we assume you print 150 things a year of similar multicolour complexity, and obviously not everyone does, but if you're using this to run an Etsy store or for other form of work, or you just love printing multicolour things, that would be 50 kilograms of material you've saved in a year just on waste material. Now, if you assume you're paying £10 per spool of filament, and a lot of people are going to pay more than that, that's saving you £500 a year just on waste material. Now, usually at this point in the video, I say something like, but it's not all good news. But really, I don't really have any complaints, especially if we're talking about the differences between the H2C and the H2D and what the Vortek upgrade would bring. That said, there are a few things worth noting.
As with other H2 printers, the airflow bypasses the air filter when printing with low temperature materials such as PLA and PETG. As a result, I will for now be fitting a Vento H2 filter from Vauxhall PLA, but I'm planning a video all about air quality with printers and various things that you can do about it and comparing how each of them perform, so keep an eye out for that soon.
The H2C has a smaller build plate compared to its H2 brethren, but it still has a sizable build volume which should easily handle what most people want to print. The induction nozzles are twice as expensive as H2D ones. At £33 for the base models, that's about $45 US, and £60, over $80 US for the high flow nozzles. And you need 6 of them, in addition to your left nozzle. The good news is the H2C does come with all the nozzles you need to get started, but they will of course need replacing as they wear out. It's also worth mentioning that, at the time of filming, the H2C includes 2 0.4mm standard nozzles, 4 0.4mm, 1 0.2mm and 1 0.6mm induction nozzles. So whilst it comes with enough to fill every slot, if you wanted to do 7 colour prints, you would need to buy an additional 2 0.4mm induction nozzles. And that leads me on to the price of the printer itself. This is not a cheap 3D printer, not by a long shot. But at the same time, there were some prosumer grade 3D printers available 8-9 years ago that were 3 times this price, and they didn't have the ability to save you hundreds of pounds a year on material usage. That said, much of what this printer offers over its cheaper H2 counterparts are luxury upgrades that I think almost anyone would appreciate, but not everyone necessarily needs, especially if budget is key. And then there's the maintenance. The Vortek has introduced some more regular maintenance that you'll want to do, which largely comes in the form of lubricating to keep it running smoothly. But time will tell as to whether it's built for longevity and whether these additional moving parts are going to hold up under intense long-term use. But this is a fantastic printer, and if you regularly print with 3 or more colours or materials, this printer is made for you. Not only does it allow you to print 7 colours or materials without concern about purge waste, but the knowledge that you can do that then expands what you'd even consider designing or printing in the first place, and massively opens up the possibilities of what you can print whilst reducing costs. I run a small Etsy store, and the H2C and H2Ds have allowed me to put many more of my designs on there that just wouldn't have been cost or time effective beforehand. Not only that, but the ability to assign materials to specific nozzles reduces the chance of blockages and under extrusion, therefore improving print quality and, more importantly, reducing the chance of headaches. Equally, being able to have multiple different sized nozzles always fitted without sacrificing the ability to do low waste multicolour prints just means it's always set up ready to print anything. Now, if you're looking to get a new printer and you are considering the H2C, these are the 3 main reasons that the H2C may not be right for you, and the first is of course the price. This is a brand new flagship printer and it has the price tag to go with it. If the price is right on your limit and you don't absolutely need one or more of the features I've talked about today, you may be better off considering another printer that's more in your budget for now, perhaps even the H2D or H2S, that would allow you to do a Vortek upgrade in the future when you've got the money. Secondly, if you rarely print with more than 2 or 3 colours or materials and you don't plan to, then the H2D will likely give you many of the advantages of the H2C at a lower price point. And then finally, the build volume. Whilst the H2C does have a large build volume, which is more than large enough for the average person's needs, there are much larger ones available. So if it's important to you that you can regularly print items that won't fit in the H2C build volume, this may not be the printer for you. For me, this is currently my main printer. Anytime I'm printing with 3 or more colours or in a different nozzle size, this is always my go-to, and not just because it's always ready to go. I've popped links in the video description to all the prints that are featured in this video, as well as to the H2C and the various upgrades that I've mentioned. What do you guys think? Are you planning on getting one, or have you already got one? In which case, how do you find it? Let me know in the comments below, along with anything you'd like me to cover in future videos. I've got loads of tutorials and deep dives planned throughout the year on 3D printing, laser engraving and general maker tech, so subscribe so you don't miss them. If you've enjoyed this video, please do pop me a like and a hype if you get in there early enough. It's always really appreciated. Thanks very much everyone, and until next time, happy printing. Hey everyone, thanks for sticking right to the end, and as always, a huge thank you to my 3D revolutionaries for supporting me and my channel. If you'd like to join them, getting early access to my videos and other goodies, hit join below any of my videos. For now, why not check out my coverage of the H2D, or pop on one of my other videos to learn something new or have some fun. Thanks very much everyone, and until next time, happy printing.